Hello everyone. My name is Nitin Sharma and I'm from CSC department of Sri Venkateswara College of Engineering. My technical seminar topic is Brain Computer Interface. So, the topics we are going to cover in this will be Introduction to Brain Computer Interface, the science behind Brain Computer Interface, early works of BCI, applications of BCI, projects which have been done on BCI, challenges and limitations of brain-computer interface, future of brain-computer interface, and at last the conclusion. So what basically is the brain-computer interface? The BCI is a technology that allows direct communication between the brain and an external device, such as a computer or a prosthetic limb. The BCI is based on the principle of neuroplasticity, which refers to the brain's ability to adapt and recognize itself in response to new experiences. BCI has the potential to revolutionize the way we interact with technology and with each other. With BCI, people with disabilities can communicate and control their environment using their thoughts and can talk to the normal peoples. The science behind brain-computer interface. BCI is made possible by advances in neuroscience, computer science, and engineering, electroencephalography, functional magnetic resonance imaging, and magnetoencephalography are some of the neuroimaging techniques used to measure brain activity. Signal processing algorithm and machine learning techniques are used to interpret the brain signals and translate them into commands for the external device. The success of BCI depends on the quality of the signal acquisition, the accuracy of the signal processing, and the user's ability to generate consistent and distinguishable brain signals. So, what basically is a BCI? It's a device or a technology which is implanted in the human brain and is connected to a external device which we can say a computer. So if a person with a disability, if a person who is not having an arm, we make a external arm, a metallic arm, and implant to the person, and we make a chip, a BCI chip, and implant it in his brain. Now the brain cells will send a signal to the device, and the device will do the work. Like suppose if a person wants to write something, now the brain cells will send the signals. Now the BCI chip will convert these signals into an algorithm and give the command to the hardware, to the to the out layer. Now the arm will do. It will write. If I want to do anything with my arm, it will do that. So now the early works of BCI. Algorithms to reconstruct movements from motor cortex neurons which control movement were developed in 1970s. So basically the first time BCI was invented or some invention was done on the basis of BCI was in 1970. The first intracortical brain-computer interface was built by implanting electrodes into monkeys. Now, the first experiment was done on monkeys with giving an external arm to them. They took a monkey who didn't have an arm. Now they had put it in chip, a BCI chip, implanted the chip in the monkey's brain, and they monitored what the monkey is thinking, what he is doing with his hands. After containing initial studies in rats during 1990s, researchers developed brain-computer interface that decoded brain activities in monkeys and used the device to reduce movements in monkeys and used the device to reduce monkeys' movement in robotic arm. Now the application of brain-computer interface. BCI has the potential to transform many fields, including healthcare, education, entertainment, and gaming. Now, in healthcare, BCI can be used to restore lost sensory and motor functions in people with paralysis, stroke, or spinal cord injury. As we have talked earlier, like if a person is not having an arm, now the BCI can give him the feel of an arm. Like he can do whatever he wants to do with the metallic arm. BCI also can also be used to diagnose and treat mental disorders such as depression, anxiety, and ADHD. In education, BCI can be used to enhance learning by providing personalized feedbacks based on the student's cognitive and emotional state. In entertainment and gaming, BCI can provide a more immersive and interactive experience by allowing the user to control the game using their thoughts. Now, suppose if we are playing a game, now what if instead of using mouse or keyboard, we play the game just by our thoughts? So this is what BCI can help us to do. We can now play any game with the BCI just by our thoughts. If I want my character in a game to move forward, to fire a gun, I can do it without using my keyboard, my mouse, just by my thoughts. These are all the applications of brain-computer interface. Also, provide disabled peoples with communication, environmental control, and movement restoration. Now the people with disabilities. We can take an example of as we can take the example of Stephen Hawkins. He was unable to walk, he was unable to talk, but his computer, what he was thinking, what he thought, the computer gave him the voice. That was only because of the BCI, which helped him to to communicate with the other peoples, to uh, control the environment, to move forward, to move backward. This also provided enhanced control of devices such as wheelchair vehicles or assistance robots for people with disabilities. Provide additional channels of control in computer games. Monitor attention in long-distance drive work or aircraft pilots. Send out alerts and warning for aircraft pilots. Develop passive device for monitoring functions such as monitoring long-term drug effect, evaluating psychological state, etc. Now we'll talk about the projects on BCI. So there are some projects on the BCI which are BrainGate, PCI 2000, Australian Bionic Eye, Honda Asimo Control, Kevin Bob with the first human cyborg, gaming control, and many more. So we'll basically talk about 2 and 3 projects on BCI. First is BrainGate. So what basically is a BrainGate? BrainGate consists of a sensor implanted in the brain and an external decoder device which connects to some kind of prosthetic or other external objects. As we have earlier talked, the chip will be implanted in the in the human skull. Now the chip will take the signals from the brain cells and it will convert the signals into an algorithm, and these algorithms will give a command to the outer part, to like an arm. Like we are using an arm, we are giving a disabled person an arm. Now they can move his arm just by thinking of that. The sensors is in the form of microelectrode array, formerly known as the PATHA array, which consists of 100 hair thin electrodes that sense the electromagnetic signature of neurons swimming in specific areas of the brain. For example, the area that controls arm movement. So as we can see this image, this is the area of the chip. Here the chip is being implanted. Now whatever the person is thinking, he can get on the screen, whatever he thinks. Now whatever he wants to do, he can do with his arm. He can do with the machine. Now if a person without mouse, he can move the cursor in his computer just by using BCI. So Now we'll talk about what is the need of a brain gate. So the brain gate was developed to help people with paralysis or accidents or suffering from disease that have lost control of movement. This technology is embedded in the scalp of a person's head and converts his thoughts into movements of the cursor on the computer screen, as I have shown you. This technology works because of the way in which our brains functions. Our brains are filled with neurons that are connected to each other using dendrites and axons. Our neurons are at work whenever we are thinking, moving, feeling, or remembering something. The work is done by electric signals of about 250 amperes. These signals occur due to the potential difference of the ions on the neural membrane. Now, the next project of PCI is Honda Asimo Control. Now, Asimo is a bipedal humanoid robot. Honda has been developing with a goal to develop robots with that will coexist with and will be useful to people since its first introduction in 2000. In 2011, the latest version was introduced with world's first autonomous behavior control technology. Now, the ASIMO stands for, as the A stands for advance, S stands for step in, I stands for innovative, M stands for mobility. This is what an ASIMO is. ASIMO is nothing but a robot which is controlled by a human being. Like we play a game, we play a remote control car. The car is moving. Why? Because of the controller. The human which is controlling it can move, increase the speed, can make the car turn right, can make the car turn left. Exactly that happens in Asimo. Here the person will get an EEG, electropotential charge. Now he'll get a chip in his skull implanted. Now he can control the Asimo. He can make the Asimo do whatever he thinks, whatever he wants to do. Just by thinking he can do that. He don't have to move his hand, he don't have to walk. He can just do it with his thinkings, with his thoughts. Asimo. Now advancements of intelligence capabilities. Honda has developed a new system that is a fundamental technology for advanced intelligence, which comprehensively evaluates inputs from multiple sensors that are equivalent to the visual, auditory, and tactile senses of human beings, and then estimates the situation of the surrounding environment and determines the corresponding behavior of the robot. Now, Passimo becomes capable of responding to the movements of people and the surrounding situations. For instances, Passimo will stop its current action and change its behavior to accommodate the intentions of the other party. Now, if Passimo is communicating with you, now he will notice you. He will do everything to match your intelligence. Like if you are talking to him, he will talk back to you. If you are saying to do something to the Asimo, we will do that. Coordination between visual and auditory sensors enables Asimo to simultaneously recognize a face and voice. Now, if we are talking, if we are in a group and everyone is talking continuously at the same time, now our mind, our human beings will not understand what a particular person is saying because of the noise created by everyone. But it is different with Asimo. He can recognize the voices of multiple people who are speaking simultaneously, which is difficult even for human beings to accomplish. So these are the examples of PCI. Now, Asimo is capable of predicting the directions of a person. A person will walk within the next few seconds. Now, as we can predict as we can predict tomorrow's weather by just seeing today's weather. Similarly, ASIMO can also do that. We can predict the human being's next step just by uh, just by seeing their previous steps, the next few seconds based on information from preset space sensors, and quickly determine to take an alternate path to avoid a collision with the person if the estimated location of the person and the ASIMO interacts. Now, advancement of physical capabilities. The combination of strength and legs. Now, the ASIMO is very capable of, have very physically capabilities. His legs are strong, he can run forward, he can run backward with the same speed. ASIMO can walk, run backward, hop on one leg or two legs continuously as a result of acquiring the ability to make such agile motions. ASIMO has become capable of more flexibly adapting to change external situations so that it can, as an example, walk over an uneven surface while maintaining a stable posture. Now the next example is eyes can say a lot. In this, we can predict, we can know that what are eyes saying. Suppose two persons are sitting facing each other and they are just signing with their eyes. They are talking with their eyes without saying any word. They are just saying something in their mind. Now, the BCI can also detect this. They can detect your eyes motion, they can detect your brain cells, and they can tell you exactly what you are saying, what you are thinking, what your eyes are thinking, where your eyes are looking. So, the virtual human is the basis of human-computer interactions. The eye tracking system is becoming increasingly popular in this modern technology area. This work concentrates on the threshold of eye tracking practicality. The eye movement interface uses HCI research mechanism for better achievement and communication system. Now, what are the challenges and limitations of PCI? Despite its potential, PCI still faces many challenges and limitations. One of the main challenges is the variability and complexity of the brain signals, which makes it difficult to extract meaningful information. Another challenge is the invasiveness of some PCI techniques, such as implantable electrodes, which carry risk of infections and tissue damage. Obviously, if we are implanting some outside material, some metal from outside in your body, they may cause you some infection, they may damage some your tissues. Now, VCI also has limitations in terms of speed and accuracy, which can affect its usability and effectiveness. Moreover, VCI raises ethical and privacy concerns, such as the possibility of mind reading and manipulation, and the ownership and control of the user's brain data. Now, this is also one challenge for the BCI. The mind signals can also manipulate it. We can manipulate the mind signals. Sometimes the technology we are using is not up to the date. So the output we are getting is sometimes wrong, but it's sometimes. And now, the future of PCI. Despite the challenges and limitations, the future of PCI looks promising. Researchers are exploring new techniques for signal acquisition and processing, such as optogenetic and nanotechnology. They are also developing non-invasive BCI techniques, such as transcranial magnetic stimulation and functional near-infrared spectroscopy. In the future, BCI could become a ubiquitous technology that seamlessly integrates with our daily lives. It could enable us to communicate and interact with each other in new ways and enhance our cognitive and physical abilities beyond our natural limits. So BCI can give us something like we can talk without our mouth, without using our mouth. Yeah, it can be happen. Just like we can take the example of Stephen Hawking. He talked to the everyone without opening his mouth, just by his brain signals, and that was accurate. So we can see these type of things in the future, that peoples are talking in a new way. They may talk with their eyes, they may talk without opening their mouth. In we don't know with any other way. So yeah, it can be possible with the BCI. Now the conclusion. Brain computer interface is a fascinating and rapidly evolving field that has the potential to transform many aspects of our lives, while there are still many challenges and limitations to overcome. The possibilities are endless. As we continue to explore and develop this technology, we must also consider its ethical, social, and legal implications. VCI is not just a technological innovation, but also a reflection of our aspirations and values as a society. It is up to us to ensure that BCI serves the common good and promotes human flourishing. Now, we can do many things with by just using BCI with brain computer interface. Right? I think in our future, we will be innovating many such technologies which we can use, which will make a human complete if he is having any disability, rather than that it will be complete for him. He'll be considered himself as a complete by using BCI. Thank you.